Since we are talking about membranes, we're going to be covering a concentration profile inside a membrane. So after you open the animation, you will get this, the membrane concentration profile. You got the diffusion constant for the material. You got the membrane thickness. You got the equilibrium constant. The demonstration shows the concentration profiles on the feed and permeate sides of the membrane. Essentially, it will have two concentrations, the concentration of the feed and the concentration of the permeate. More importantly, we're going to have concentrations at the interfaces, okay? And if you want to check out more on the mass transfer concepts, go and check it out here. What I will be doing is I want to modify the diffusion constant. I know that if the constant is large enough, mass transfer is going to be large enough. Okay, here it goes, the flux. Look at the flux right here. The flux is going to increase because I stated before, more diffusion constant, more mass transfer. Let me go back to something in between. Membrane thickness. I know for sure that if the membrane is very thick, mass transfer will be limited. And if the membrane is not thick or is slim, it will be a very high mass transfer. So let's check out. Yes, it occurs, so it increases. If I go to the right, it increases as well. Interestingly. Now the equilibrium constant, that's related to this part right here. Equilibrium constant K, no, wait. Let's see if we can find something. Equilibrium. Okay, K, so large K, as you can see here, the flux through the membrane can be written in terms of permeance, and the permeance is given by the diffusion, the length, and K. So apparently, the permeation is directly proportional to the equilibrium constant, meaning that if I have a large amount of equilibrium constant, the flux should increase. Let's see if this is true. Yes. Fortunate, this is true. Great. And what I want you to check out also, guys, is how changing these bars affects the concentration profile. So for instance, the thickness will near this in the x-axis. The diffusion constant changes this in the y-axis. So the concentration changes. And the equilibrium constant shifts the line or the difference between the concentration in the interfaces.